We are studying trigonometry. And really, trigonometry is the study of triangles, and particularly, we are interested in right-angled triangles. Although in grade 11, what we start to realize is that actually all triangles can be made up as combinations of right-angled triangles. So if I give you like an acute, and you may say, oh, there's no right-angled triangle there. Well, what if I cut it in half? And then I have two right-angled triangles inside. And then you may say to me, well, what if you have an obtuse angled triangle like that? And then I'd say to you, well, what if I tell you you can have a big right angled triangle and a little right angled triangle and give you the small one here? So that we have sneaky ways of bringing other triangles into the party. But the main focus for today is just going to be on the good old fashioned right angled triangle. And when we talk about right angled triangles, we give the sides names. So we call the side opposite the hypotenuse, we call it big H, opposite the angle or the reference angle, big O, and then opposite the other angle, or the only remaining side is A for adjacent. And most of you will have learned the acronym SOHCAHTOA to summarize the trig ratios. Now, in grade 10, we only deal with trig triangles basically in free space. We don't put them on the Cartesian plane. And you basically learn how to write out trig ratios. You learn how to solve for sides. And you also learn how to solve for angles using trig ratios. So that's what you do in grade 10. And we're going to do some warm-up questions today just to check you're okay. But the main jump from grade 10 to grade 11 for trig is going from this first drawing to the second drawing. And I would like to know, what are the main differences between the first drawing and the second drawing? So there's stuff that's the same, but there's some stuff which is a little bit different. So what do you notice that is different from drawing 1 to drawing number 2, or block 1 to block number 2? Who wants to let me know? Who's feeling like they want to share some knowledge? Siamtanda, Sange, Atlechang, Amelia, Amakle. Who feels like they can help their classmates by pointing out what is the same, what is different? What's the main difference that jumps out at you? What are these things? What is R? Why is there an R here? What is R the same as? So CM Tanda has spotted, yes, this is on the Cartesian plane. And what we notice is R, or what we call the radial arm or the radius, is the same as the hypotenuse. And then we notice that the adjacent is the same as the distance along the x-axis, and the opposite side is the same as the distance along the vertical axis. And the way I summarize this is I think of yo, like yo. So y goes with O, so I remember that goes, and then I remember A goes with X, so I just remember X, and then what's the only one left behind? It's the H goes with R. So O, so is Y is for yo, and that's for X. So we have to be able to understand trigonometry in terms of O, A, and H, and also X, Y, and R. Now, the reason this is so helpful is it allows us to describe triangles on the Cartesian plane. And the reason that's useful is that we can then talk about triangles that are greater than 180. And you may say to me, hold on, Mr. S, I thought triangles only go up to 180. How can you have triangles with angles bigger than 180? Well, let's do this. Let's pretend I'm in quadrant 1, and I'm going to draw a triangle, and that triangle is going to have an angle of 30. And I want to know what is the ratio. So this is going to be y, or it can be o if you like, depending on which thing, over here. Oh, let's leave it as y. This one over here is going to be x, and this one over here is going to be r. If I write the sine of 30, what I mean is, what is the ratio of y over r? Or if I was using this thing over here, it's the same as over h. Now put in your calculators, what do you get if you type sine of 30 in? Can someone tell me what you get? What do you get if you put in your calculators the sine of 30? We get a half, absolutely. So one way of visualizing that half is to say, well, this must be a 1, and this thing over here must be a 2, because it's y over r. Okay, but now what I want to suggest is that you can actually have a right-angled triangle following the definition of trig with 210. But to visualize 210, I actually have to go 180. So let's actually do this. 0, 90, 180, 270, 360. Now, if I stop there, that's 180. But if I keep going, I will get to 210. Now, what I do in trigonometry in grade 11 is I form a new triangle, or some teachers call it the wedge. And I want to know, if you know this big blue bit is 210, what size is that red dot over there? So I'm going to try and work out now using this what the sine of 210 is. And what we're visualizing is we know it's 180 to there. I want to know, what do I need to add? What size is that red dot there? What size is my red dot? Who can enlighten me? So Sange is quite correct. That is 30. So that is 30. So the sine of 210. Now, earlier on, when we drew our one above, we noticed that in quadrant 1, x, y, and r are positive. If I look at x, it's in the positive axis, y is positive, and r is always positive. But if I look at where x is now, where y is now, and where r is, what can you tell me about x? Now, r is always going to be positive, okay, because it's a radius. But what can you tell me about x and y? Are they going to be positive or negative based on their position in the triangle? For 210. So both this x is going to be negative. So this is actually going to be negative x because of its position. And this is going to be negative y because of this quadrant. Now let's try and work out what the sine of 210 is. The triangle, well, sine of 210 is just, remember what we said earlier on, sine is just y over r. But in this case, the sine of 210 is just going to be, if I look at where it is, it's going to be minus y over r because of its position. Now type into your calculator the sine of 210, and what do you end up getting? What do you end up getting if you type in the sine of 210 in your calculator? Do you get a half, or does it change somewhat? So we know, okay, so we get in your calculator, what you're going to notice is the sine of 210 is minus a half. And the reason it's a minus is because of that minus that's sitting over here, because it's in what we call quadrant 3. So something that we need to start to get used to with trig in grade 11 is we talk about what quadrant does the angle form in, or what quadrant does the triangle form. And so we say this quadrant here is quadrant 1. Sorry, this, I lie. I tell a lie. This is quadrant 1. This is quadrant 2. this is quadrant 3, and this is quadrant 4. And what we say with the sine of 210 is the sine of 210 falls inside quadrant 3. And it looks like if I get sine in quadrant 3, I end up with a negative value. Now, some of you will have never seen that before, but does the idea that I can explain with this drawing that the sine of 30 is a half, but the sine of 210 is minus a half, just because of the quadrant it's in. Does that make sense? Can you give me a thumbs up if you can follow that? Give me a thumbs down if you don't follow that basic idea. Okay, so basically, it's still the same 30-degree triangle. It's just that the quadrant it's in is different. That's why the value is still the same, the lengths are still the same, but it's because it's negative because it's in that quadrant. Okay, now we're going to explore that lots in the next lesson. Back to the trig that we were doing. Now I'm going to switch it up a little bit in the second lesson, in that we're no longer going to be looking for ratios, we're looking for unknown sides. Now what's going to be different now is that we are going to say, we're going to have to find what A is. And the way we're going to do it is we're going to say, look, we want the yellow one. We are given the 16 and we are given 31. I'm going to give these guys names. This is going to be my H. This is going to be my O. This is going to be my A. Now, the only stuff that I have information for is the A and the H. What trig ratio is involved for A and H? What trig ratio? So if I look at the drawing, I've highlighted, I need to know what A is. And so what we're going to say is, look, we know we need the trig ratio cos. What is the angle we're using it for? It's the cos of 31. And if we look at what the A actually is, it's just a little a. And then on the bottom where we have H, we're going to have 16. Now you need to rearrange this equation, this trig equation I built for you, to figure out what is A by itself. And then you need to choose the option that's correct here. So choose the option that is correct there. We're going to have to get our calculators out here. So we're going to have to bring the 16 to the other side. And it becomes multiplied by 16. And we go 16 times cos 31. And I get, in my calculator, I get 13.71, etc., which means the correct answer must be A. So now we're using trig to find unknown sides. So let's see if we can do some more of this. I want to know what is the length of side A, and I want you to try and do this by yourself. The only tip I'm going to say is I'm going to say this is actually big O, that's big H, that's big A. But I want you to try and figure out what the length of the side is and then choose the correct option all by yourself. And then you can raise your hand if you have any questions. And I would love to take questions if students feel like they have some. So the one that I have is here. Okay, so what involves O and A, it's going to be tan. So I'm going to write the tan of 15 is equal to A over 21. And so then this 21 needs to come to the other side. So we get A is just equal to 21 times the tan of 15. And if I use my calculator, I get 5.62, which would be this one over here. Give me a thumbs up if you're following this. Give me a thumbs down if you're not, because I'm still not sure how much trig you guys have done. But I know students always think they understand this, but they very rarely have enough time in class to really go through it thoroughly. And so today is all just about rebuilding the basics from the bottom. Okay, and don't be shy if you give me a thumbs down. I don't mind. I need that information from you guys to really just keep on swimming. Okay, let's do another one. Find me the length of side A here to help me choose here. What do we think it is for this one? So we know that's big H, that's big O, that's big A. We're given H and we want O, so the trig ratio that involves O and H is sine. So the sine of 64, because we know O and H are go in the trig ratio, so it's going to be A over 10.8. And then we have to move this 10.8 to the other side. So we're going to get 10.8 times the sine of 64. And using our calculator, so 10 times the sine of 64. And we should get 8.9. Oh, what have I done? 10.8 times the sine of 64. I feel like there's maybe an error in this question. Did I do something wrong? Let's have a look. Over H, so that's O, 10.8 times the sine of 64. I get, this side my calculator's gone to sleep. Let me try again. 10.8 times the sine of 64. Oh, here we go. 9.70. So that the correct answer is C. Okay, so we've learned today about using basic trig ratios. We've learned how to use trig ratios to find sides. The last thing we're going to do today is how do we find unknown angles in right-angled triangles. Okay, so now we're finding angles. So what you're going to notice is in this question, the thing that is the mystery is the x. You are given one side over here, and you are given another side over here. And the most important thing is you need to classify them. So this is O because it's opposite the mystery angle. This is H. What trig ratio am I going to use to find my mystery reference angle X? What is going to be my mystery? It has to be sine. But now we've got a bit of a problem, ladies and gentlemen, because the sine of X is over H. But my X is locked away inside the sine function. And so what we need to do is unlock it. And the way we unlock it is what we call inverse sine. So we apply inverse sine to this side, and we also apply inverse sine on that side. And if we do that, then we get the X all by itself. On our calculator, we just go shift sine, and you'll see the inverse or arc sine there. So I want you to work out, if you go shift sine and then fraction button 7 over 10, what answer should I choose? A, B, C, or D? So I'm going to do it with you. I go shift sine fraction button 7 over 10 close. And what option are you guys choosing for your correct answer? How big do you think this angle is over here? I'm getting 44.43. And so 44.43 the correct option has to be B. This is close, but no cigar, 44.43. So now we're using trig. We have to use the inverse trig function to help us unlock the x that's hiding inside the trig function. Okay. I feel like people have mostly got that. If you haven't, you can watch the recording, but let's practice another one like that. Can you find me the size of angle X over here? Now it's a bit blurry. Sorry, guys and girls. It's hiding up here. There's angle X. You're given 10 and you're given 8. So this is O, this is A, this is H. What is the size of this angle over here? So I need to use a trig ratio that has O and A involved. So I'm going to write the tan of X is O over A, or 10 over 8. But now you have to unlock the X. You have to unlock the X. And how do you unlock the X? You use your inverse tan function. You don't always have to write this, but I'm just showing you so you know how the magic happens. And what do we get for X? So shift tan fraction button 10 over 8. That's what I type in. And I'm getting 51.34, which goes to C over there. Okay, look at us. We're finding angles, no problem, like we're pool players here. Nicely done, Gando and Nomfundo. Okay, I think we should do maybe one more of these, and then I think it's almost time to wrap up for today. So find me the size of angle X over here. And you are flying solo now. I just want to see what choice you give in the bottom. Is it A, B, C, or D that you think? So you always have to think, what are the correct ratios to involve? And that goes from where these things are. So if you look at what we've got an H and we've got an A. So we know that the cos ratio is the one involved. The cos of X equals A, so it's 5 over H, which is 8. But now, and so I've taught you how to use inverse cos. So I go inverse cos 5 over 8. So shift cos, then hit the fraction button, 5 over 8. And what are you guys getting? I'm getting 51.32, which is going to round off to A. So A is the correct answer. Awesome. Okay. Last one of the day. Last one of the day. According to the diagram, what does the tan of 45 equal to? And this is a special triangle that we spoke about earlier in the lesson. If this is 1 and this is 1, by Pythagoras, this has to be square root 2. Which of these 4 options do you think is the correct one? Which one? What does the tan of 45 equal to? That's H. Now, it actually doesn't matter because it's isosceles. It doesn't matter which of these you choose. What is the tan of 45 equal to? Well, this is not an angle question. This is a give me a ratio. We know it's O over A. Well, O over A is just 1 over 1. And so the correct answer is D. Okay, everyone, that is today's lesson.